Hello, Algebra 2 honors students, just got a quick video on graphing linear equations, something you have learned in Algebra 1. I'm just kind of refreshing your memory in case you need it. Some of you might not. But this video really just goes through how to graph an equation. If I give you the equation, how to sketch a graph. Okay, there are other questions I could give you, like write the equation that goes through these 2 points or something like that. But this video only covers, if you're given the equation in various forms, how to draw the graph, all right? And these will just be like typical equations, like not just horizontal or vertical lines, but just generic linear functions, okay? So one kind of equation, one kind of a form of the equation I could give you, probably the easiest form, is slope-intercept form, y equals mx plus b. Again, it's called slope-intercept form. If you're given this form, keep in mind that the value of m is the slope, which represents the ratio of the rise to the run on the graph. Another way to describe slope is it's the change in y for every change in 1x, okay? And b is the value of the y-intercept, all right? The place on the line where it crosses the y-axis. All right, so if you're given an equation in slope-intercept form, it's pretty easy to graph. All you've got to do is first to plot the y-intercept, plot that point, and then from that point, count up or down, and then to the right according to the slope, all right? So let's do an example or two, and I'll tell you where some people make mistakes. It's hard to do this on a whiteboard because I don't have a grid. You really want to use a ruler here if you have paper, so I'll try to be as neat as I can. All right, so you have the equation y equals 2/3 x minus 6, okay? So that is a linear equation with a slope of 2/3. Slope is not 2/3 x, it's just 2/3. And the y-intercept is -6. So on the graph, what's expected of you is to plot a point on the y-axis at 0, -6. And then from there, you would count 2 up and then 3 to the right to draw this, okay? So we go up 2 and then to the right 3. We're at the point on your grid, which you'll always have, 3, -4, right? We go up 2. From -6, you're at -4 for y, and you're going to the right 3, so you're at 3 for x. And now that will be enough. 2 points determine a line. So once you have that, you can just drop your ruler and draw that line. Now, personally, when I'm doing this, my answer keys, it's really easy to find some more points just to ensure some accuracy. So what you might want to do is keep counting, like go up 2, another 3 over, or go backwards, go left 2, down 3, all right? So just a thought about how to ensure some accuracy on your graph. But at minimum, you should plot these 2 points and connect the dots carefully. All right? That's the graph of this. Now, keep in mind, the slope is positive, right? Whenever the slope is positive, the graph's going to go up, left to right. The graph's going to increase left to right if the slope is positive. All right? So that's one way just to double check, make sure you didn't make a mistake. All right? Let's do another one. Let's use a whole number. Let's say -3. And let's just go +1, why not? All right? So here the slope is -3, and the y-intercept is +1. So we would start the graph at +1, right? 0, 1. And now the slope is a whole number, right? When the slope is a whole number, the way we translate that to the graph is, it's like, you got to think of it like -3/1. All right? So we would go down 3, and then to the right 1. All right? So if the slope is negative, you're going to go down the rise. Okay, so we go down 3 to -2, where y is -2, and go to the right 1, and we're at the point 1, -2. All right, so some people get this wrong and they go like down 1/3 or something like that, but it's 3/1, right? So rise over run, down 3/1 from there, and you're here, and that's enough just to connect the dots, draw the graph. All right? Of course, if you want to find some more points, you could go to the left 1 and up 3, right? Left 1, up 3 will get you some other points there. Whenever the slope is negative, the graph's going to be going down left to right. Good way to check your work, all right? So that's just a review of how to graph from slope-intercept form. Let's now graph from what's called standard form. All right, ax plus by equals c. And then we'll call it a day. So if you're given standard form, none of these values are really the slope is not in here, the y-intercept is not in there. The way you graph from this form, well, there's 2 ways. First of all, if you wanted to, you could solve for y. Get y by itself, and then it's in slope-intercept form, and then you can do what I just showed you how to do. All right, but there's a faster way usually. So you're given a problem like 4x plus 2, let's make it plus 8y equals, say, 16. All right, so that's an example of a problem in standard form. Now, you could solve for y here, subtract 4x, divide by 8, and then you'd know your slope and your y-intercept. But you should know another way to graph this, and that's using both the x and the y-intercept. So we're still going to use the y-intercept, but we're also going to use the x-intercept to find that second point, because you always need 2 points to graph a line. So for the other stuff we just did, we used the y-intercept, and then we used the slope to find that second point. But when you have standard form, one way to do this is to find the x-intercept and to find the y-intercept, and then you would have your 2 points that way. Actually, very easy to do. Whenever you're asked to find an x-intercept on a graph, think about the graph. The x-intercept is the point on the x-axis where the graph crosses. But anywhere on the x-axis, the y value is 0, right? Any point here, this point here might be 3, 0, negative 3, 0, negative 10, 0. Y is always 0. So if you plug in 0 for y, and solve that for x, it's very easy. This term goes away. Divide by 4, you get x equals 4. So 4 is the x-intercept. Plot the point 4, 0. And for the y-intercept, do the same thing, but for x, you plug in 0. Right? Anywhere on the y-axis has an x-coordinate of 0. Now this term goes away. Divide by 8, you get y equals 2. So 2 is the y-intercept. So 0, 2. And now connect those 2 dots, and you have your line. Okay? So if you did this using slope-intercept form, you wouldn't have probably plotted those 2 points. You would have ended up having the y-intercept and then using the slope to find your second point. That's fine too. All right? But especially when the 2 coefficients here clearly go into this number, it's going to be really easy just to plot this using the x and y-intercept. All right? So just plugging in 0 for x always in any equation gets you the y-intercept. Plugging in 0 for y will get you the x-intercept. Plot those 2 points. All right? And even from this graph, we know what the slope could be, right? Because to get from here to here, we've gone down 2 over 4, which is the same as going down 1 over 2. So the slope of this graph would have been negative 1/2 if you had done it that way. All right, just another point to make. All right, so from this video, hopefully you've got a refresher on how to graph linear equations from slope-intercept form and from standard form, and it'll be a few problems just to practice. Obviously, we're going to take this to the next step coming up soon, but this is definitely a prerequisite to handle the unit on linear functions. All right, have a nice day.